I'm the manager here at the NIAC lab. I'm also a manager in a couple other labs in the facility. One's called the Human Factors Lab, and another one is actually located in Daytona, Florida, and that's called the FAA NextGen testbed. And as a manager here, I kind of oversee all the activities in the lab. I help with the budgeting, and I kind of bring projects in that we need to work on for NextGen research.
I am the virtual reality specialist over at the Research Development and Human Factors Laboratory. My job is predominantly working with VR to create architectural simulations. We will go and take any sort of blueprint, schematic, any sort of pictures or anything of the sort, and create a 3D model from that. And we'll go and take that, and instead of just creating like, here's the 3D model, we're going to hand it over, we go and create a human factors sort of spin on our deliverable. We go and create virtual walkthroughs, we go and show AI-controlled humans sort of working out different operations within the workplace, and we come up with a whole litany of different design ideas and concerns for our customer to go and consider when building up this new space.
I'm an electrical engineer here at the FAA Tech Center, and my specific role, I am one of the project leads here in the NIAC, the NextGen Integration Evaluation Capability. When a project comes in, I usually deal with the external customers that aren't familiar with the NIAC and the Tech Center, so that I can explain the different parts of the lab and what services we offer, and find out what the requirements are, and then match them up to what we can do, and help walk them through the process of getting all the requirements down and then breaking them down into tasks, that kind of thing.
I do software development back here for the air traffic control simulations that we have. And when I first got here, we was working with the spacecraft shoot-offs, the space rockets, and now you see SpaceX like launching them every week at least. And we're just trying to, you know, it's kind of like saving people's lives, because we cut down on the airspace of where the rocket goes, and let the air traffic controllers know that, you know, to get these aircraft out of the way in case there is an explosion. So the software development, you know, field continues to change, grows in different ways. So you're always learning, which is good.
We're really preparing the community for the next generation of air traffic. We're making the skies safer in here, but the skies that we're going to be seeing 10 years from now.
So I think almost all the services that this building offers, most of the public has no idea about. All of the research for the Federal Aviation Administration comes through this research building here. It is the only building set up for what we do. It's all next-gen research. We also have test beds upstairs for current systems that are in the field. So if there's any issues or bugs in the system, they can come here and test it and fix them in-house.
In this facility, and as well as the Human Factors Lab, we do a lot of testing in here for new interfaces for the pilots to use. Since we are dealing with the cutting edge of technology, a lot of new technology is being brought into the field to send data communications to different aircraft via just typing a quick command instead of having to talk to it over a radio.
And all the information that comes through here goes out to different investigators and different people that want to learn what's the next step for the FAA, what's the next thing we can do to make this place better and make air traffic safer. And all that information comes through here, so I think most people don't have any idea what we do here. There's so many different opportunities here. Me personally, I started as a computer scientist. I was a programmer, and I basically spent a lot of time when I was younger learning how computers work and learning software engineering and things like that. When I came out of college, I got a job here at the FAA Tech Center doing air traffic control simulation work.
In terms of education, a bachelor's degree in electrical engineering for the job that I hold, which is in electrical engineering.
I myself, I majored in electrical engineer and moved more towards software programming. And I guess the biggest thing is, you know, enjoying, you know, what you do to help out, get you through day by day.
always had an interest in how things work, and I always had an interest in trying to figure out stuff. Even when I was in high school, trying to figure out, you know, the big question, what are you going to do? What are you going to major in? I actually started off as a math major and switched to electrical in my sophomore year.
Everything that I work with, from the programming to the 3D modeling, involves kind of an idea of a lot of linear algebra, trigonometry, calculus.
I think, again, depending on the field you're coming in, the qualities you need are different, but there's something for everyone here.
Sort of now a big boom for young people to get into technology because it's so much more easier to get into. Young people getting involved will allow them to use more modern technology that will be more capable of handling the needs of the airspace today.
A lot of things in here that you get to experience that you'll never experience somewhere else. In this lab alone, the simulation capabilities that we have with a cockpit simulator, VR lab, and everything, you get to see different things, and it's a top-of-the-line technology. You won't get to see this outside of here. The first thing that's going to happen in air traffic will happen here, and you'll know before everybody else. And it's a really cool thing to be able to come in and see that.
The fact that there's research labs that are working with UAS drones and cockpit simulators and tower simulators, and we're working on trying to integrate in new technology while keeping the air traffic safe. The fact that there's software developers working on bug fixes to the existing systems out in the, we call it the NAS, the National Airspace System. The fact that there are developers here working on new code for systems that aren't even being deployed. It's all done here at the Tech Center.
This facility here utilizes a lot of really cutting-edge technology. This is the next generation of technology that controllers will be seeing in not tomorrow, but 10, 15 years down the line. So all this technology is really brand new. It's in its infant stages. We're still learning about how we can better use this technology, and we're testing out those ideas in this facility here. So we can go and explore what kind of things are going to work for air traffic controllers, what kind of things can we improve upon, and how can we take the limitations of today and eliminate them in 10 years from now.
So, I mean, if you're interested in programming, and this is an excellent opportunity here, especially with the state-of-the-art things that we have here, and you're right on the cutting edge of, you know, developing software.
I've really been very blessed that I chose electrical engineering as a field and to work for the FAA. I've been working for the FAA for over 25 years, and I'm thrilled.